Hey all, welcome to ShareTreck. This is Raj here. You might recall that in the early days of our channel, when we started covering genomics, I had done videos on fundamentals of CRISPR-Cas9, DNA, etc. That was my way of understanding genomics so that we could make some sense out of what we are doing with genomic shares, understanding the companies that we trade in. Now it's the time to learn AI ecosystem so that we can, as investors, make informed investment decisions. I'm sharing with you what I have learned so far in the last few days. Your feedback in the comment section is welcome. And that said, let's dive into the world of AI. Welcome back, friends. We are going to discuss the architecture of the AI field and briefly review various elements of this infrastructure and try to identify companies associated with each element. We also get a rudimentary understanding of how AI works. Known for their widespread use in AI, NVIDIA's GPUs excel in parallel processing, handling multiple tasks simultaneously. This parallelism is crucial for AI workloads that involve vast datasets and complex calculations. NVIDIA's CUDA architecture further optimizes the execution of parallel tasks, making their GPUs a cornerstone for AI applications, which basically requires substantial computational horsepower. And then if we look at Google's TPUs, in contrast, Google's tensor processing units are custom-built hardware designed for explicitly accelerating machine learning tasks. TPUs are tailored to enhance the performance and efficiency of specific AI workloads, such as deep learning, by focusing on specialized tasks. TPUs aim to streamline and expedite the execution of intricate neural network operations, showcasing Google's commitments to efficiency in AI processing. This nuanced understanding highlights the distinct strengths of NVIDIA's GPUs in versatile parallel processing and Google's TPUs in targeted acceleration of machine learning tasks, providing investors with a clearer perspective on their respective roles in the AI hardware landscape. And then we look at advanced micro devices, which is also actively contributing to advancement in memory technology, enhancing data accessibility, and boosting processing speeds with AI systems. AMD's commitment to memory innovations encompasses a range of technologies, including high bandwidth memory or HBM, allowing to address the evolving demands of AI workloads. High bandwidth memory or HBM3E can be contrasted with GDDR9, which is what NVIDIA uses. With advanced chip capabilities and large data handling, there is need for high bandwidth. And NVIDIA uses a system called GDDR9, whereas AMD uses HBM3E, which is their fastest architecture. And I'm just going to show you a literature from AMD, which from AMD's point of view explains how HBM3E is superior to GDD architecture. So this literature comes directly from AMD.com, and where what they are saying is that high bandwidth memory or HBM blasts through existing performance limitations. And they have all these graphics, and I'll put the link to this in the description so that you can get in here and you can get into the weeds. But basically they are talking about three problems. They are saying that GDDR5, I think right now AMD has got GDDR9 if I'm not mistaken, says GDDR5 can't keep up with GPU performance growth. And second, it says is GDDR5 limits form factors. And the third problem it says is on-chip integration not ideal for everything. So that's how they are describing it, and they have some diagrams here to explain how HBM breaks the bottleneck in all those cases. So they have mounted the DRAMs one on top of the other, thereby reducing the distance to be traveled. That's how I understand this. It's called stacked memory chips interconnected by microscopic wires, called through silicon vias or TSVs. So that's what they have as architecture. And here they have contrasted HBM versus GDDR5, where GDDR5 has got off-chip memory, whereas HBM has memory within the chip, and therefore it will be much efficient. And so I'm not a very technical person, but basically when I look at graphs, I get a high level understanding, and I'm looking at HBM versus GDDR5. So GDDR5 has got lower bandwidth as compared to HBM, which is almost 3 times faster. I'm pretty sure that NVIDIA has upgraded, but I'll be doing that search going forward. Maybe in a future video, I'll talk about NVIDIA's memory architecture. And in terms of space savings also, they're talking about a smaller size chip. So overall, this is what AMD is talking about to express their point of view why their product is superior. I'm pretty sure if I go to NVIDIA website and have a look, they'll have something similar which shows that their architecture is superior. So we'll find all those things in due course. But for today, I would say that in terms of bandwidth provisioning, it's important to note that the memory subsystem, including high bandwidth memory, is an integral part of the overall architecture. Bandwidth is the context. In this context, refers to the rate at which data can be transferred to and from memory. It's the result of the combined capabilities of the memory technology and the memory controller on the processor or GPU. The specifics can vary depending on the product and design, but that's what gives the performance. And then we have Seagate and Western Digital, who are key players in providing storage solutions tailored for the burgeoning datasets in AI applications. Not only do they need to provide large storage, but also quick retrieval and reliability. It should not fail very often. And on top of that, you have to have interconnection. Intel plays a key role in facilitating efficient communication between AI components, contributing to overall infrastructure. And just if we zoom back out and look at everything we have talked about now and see how they all fit together, I would say that GPUs and TPUs are complementary. GPUs play a general purpose processing role, whereas TPUs excel in specific AI tasks, avoiding direct competition with each other. And when it comes to memory and storage, collaborative efforts like high bandwidth memory enhances data access for GPUs and TPUs, ensuring seamless integration. And then a foundational element ensuring GPUs, TPUs, and other components communicate efficiently within the AI systems is basically the networking infrastructure. So that's the other component that we have out there. I think understanding these interdependencies will aid us understand the synergy and engaging the synergy and potential areas of competition within the AI hardware landscape. I'll soon be back with more information as I check out LLMs and then the potential use cases in the industry. It's going to be very interesting because we have just scratched the tip of the whole thing. I'm starting from the hardware and then we'll go to the next level and so on. If any of our viewers are working in the field of AI or teaching AI, please let me know so that I can run things by you and we can have a much more accurate understanding of this area of business. I'm learning this for the first time so that we can start evaluating our companies in our watch list. And that brings me to an end of this video. And just to remind you, I mean, we have a new watch list of AI companies, which includes companies like NVIDIA and AMD in the hardware side. And then we have Microsoft, we have got Meta, we have got Amazon, all in the AI area. So I think potentially Apple will also get into the fray. And we have a bunch of companies like that. And our objective in this channel now is to learn about AI, all the various parts of AI, look at the people who manufacture the shovels, who look at the people who are building the factories, and then look at the products that come out of the factories. That's the way I'm looking at it. So we are at the bottom of the pyramid. We are going up step by step. Watch out for my next video. Till then, I'd like to say bye for now. See you later.